The purpose of surface treatments is to generate a well-defined and active surface with an affinity for the coating considered. It is observed that these treatments modify the roughness, morphology, and chemical composition of the surface. As a result of these operations, the substrate surface energy is generally increased. A correlation is often noted between the increased surface energy and the assembly adhesive qualities. The corona discharges have been used industrially for many years to treat polymeric films, fibers, and flat objects. This procedure is used for polyolefins, polyethylene and polypropylene, and some polyesters, polyethylene terephthalate. The electrical discharge between two electrodes is obtained under atmospheric pressure from a high-voltage alternative current. The electrical field generated excites the gas molecules, that is, air, and dissociates some of them. The charged active species may react with polymer molecules, which are activated accordingly. Machine configurations vary with the electrode geometries, the electrical characteristics, and the film speed. One of the important parameters is the electrode film surface distance, which should not usually exceed 2 or 3 millimeters. Most frequently, 20 kilovolts electrical currents are applied, with frequencies ranging from 10 to 20 kilohertz. Numerous fundamental works describe the reactional mechanisms of this type of treatment. Depending on experimental conditions, ozone and nitrogen oxides are formed in air discharges. Polymers are oxidized. Carbonyl groups appear. Peroxides could be formed, and their decomposition could result in the formation of carbonyls, carboxylic acids, ethers, hydroxyls, and ozonides. The treatment of polyolefins by corona discharge in air develops their polar character and their aptitude for adhesion. Corona discharge treatment of polypropylene sheets under atmospheric pressure shows that the best results are obtained with an oxygen-nitrogen mixture with over 20% oxygen. Alcohols, ketones, and carboxylic acid groups have been identified on the treated surface. The surface energy of treated polypropylene is clearly higher than that of the reference. The adherence level of a polypropylene polyurethane assembly is significantly improved after treatment and depends on the surface oxidation degree.